Awesome. Great to be here. I'm Karolus, co-founder in Flow AI. We are two technical co-founders, and I would say Aro is pretty technical as well. He's over there. We have been helping companies with evals for quite some time. Also, we built synthetic testing data, and more recently, we have been helping out companies that have issues with data not fitting their context window. So it seems fitting that we are here in the Context is King meetup. And the other constraint that we find brings demand for us is numeric precision. So having agents that are very accurate with numbers. And I want to talk through how we have been building these agents, starting from trajectories that could have spanned like 3-5 minutes, maybe even 15 minutes on quite complicated tasks that involve lots of data and lots of decisions. And I want to emphasize the distinction between computing and data. So computing comes out of a decision, right? And then data is just something that you want to relay. But an agent is best for decision making, but not for using as a way to relay data from place to place. So what made us realize this distinction? This is a timeline that probably a project would go if you start building on a complicated case, an agent. We have the dates sort of on the bottom, and then on the up we have duration, like median duration of a trajectory of an agent. And you can see there's an upward trend here. So the more complicated queries, maybe the more data, the more conditionals you have in the query tends to result in larger, trajectories. Simple, right? But how to reverse that trend? That's a problem that we have been working on quite a bit. And from 2.5 minutes-ish, we've now hit pretty much 30 seconds-ish, and now we're working at like something like 10 seconds base. So we've done pretty well. Observations, and coming to the context rot that we heard. So truncation, so meaning your context just truncates in a dirty way from the middle or from the end. So you have a fixed number, and then you just drop something. Could be good, depending on your task, but if you have indivisible data, so you need to keep all the precision for your decisions, then you cannot have truncation. Can you do summarization? So what if I have sub-agents maybe? Maybe they just do a search task, and then they summarize what they found. Could be plausible. You could create a glimpse data out of that, maybe in JSON, bring it back to the main agent. That could work. But in our case, still not good enough. We need the full precision all the way to the end. Bigger window. This is good. This may be one of the best solutions out of these for us. But why is it not good enough? It's the distinction again between decision making and data relay. So you're using agent as a data relay. So why is it not good to use agent as data relay? Because the agent also needs to make decisions. So you're not separating the concerns in that case, and you will have worse decisions. Because a lot of the times instructions will be at the very places where you don't want them to be in the trajectory. So take that into account. A query for us could be something like increase X object out of a catalog to a certain number with constraints, which could be various. I'll show you in a demo soon. Okay, what happens? The resolving stage. So you have a search. Maybe you do something with enums, maybe you token search. There are multiple ways you could search. Maybe you parallelize those searches, then you get eventually you resolve to a final set, like product IDs that satisfy all of the conditions. And in a case that in query you have all the products, then it turns out that this set is actually very large, too large, right? And you don't want to lug it all the way to the end, because you don't want to use agent as your data relay. So what you can do is you can remember what the agent found. Maybe a SQL query that takes in one of the conditions and it creates an intermediate set, and then you take one of the other conditions, you create another intermediate set, and then using those sets you can reduce, and then you can call it by a name, right? So it's kind of like this idea that you have an identity, then you have a value, and then you have a state, and you don't complex those things together. And then you return to the pointer, to the decision maker, the agent. And the pointer also can have governance on it, so you can mix it with the tenant ID, as we do. So you have automatically everything that you need there. And by the way, most agent frameworks have no concept of governance, so you will have to custom implement this tenancy in there. So what's wrong with this approach? Why doesn't it work? It's a terrible idea. You're taking something and then you're hiding it from the decision maker. How will the decision maker make decisions if he cannot see the full data? This is the core question. If you look at your trajectory, can you say for each step that can I hide this from the agent or not? Then you have to know pretty well what you're hiding. So you have to say, if our search produced something like 847 products in certain channels, stores, brands, price ranges, what are the attributes that actually matter for the decision itself or for a human in the loop? So question that very hard and then form a glimpse, and then base the decision making on the glimpse. And if the glimpse is off, you should have a way to get back to the full context. So I think that's like a pretty good idea. So solve the storage, and then afterwards solve the reasoning. But how you can do that is with evals. So there are certain unlocks. Once you use KVs, you will quickly realize that I don't actually want to take this data back to the decision maker. I'd rather keep it on my side. And then you'll find that you're able to fuse tool calls together without making a round trip to the very slow and old LLM. So that's what I mean by efficient handoffs. You don't necessarily even want to bring that ID back to the agent, just for the agent to bind the ID to the next tool call, because that is an error that's waiting to happen. So you might want to bring just a context ID to the agent, and then underneath that you have resolve scope ID, conditionals ID, you have lots of other IDs, and then you get a full taxonomy of errors off, because you're passing data sort of in a natural way, not via this kind of movement. Then it's obviously the latency is there, and the parallelization is one. When you do this, one mistake that will happen is that you will initialize KV stores in the tools. So you will find that you need dependency injection to be pretty good, because otherwise you just want to draw from the same pool of database in the tool call so that they can be extremely fast. And the lenses here. So like, how do you analyze your traces? If you have a system and it's producing quite good observability, that's the best situation, because you can run those traces on the most intelligent models, right? And you can ask questions on whether you should round trip some data to the decision making or not. And this will be helpful. And you can really spend time on thinking about what's needed for the decision, because that will give you the idea of what the glimpse should be. Every handoff is an opportunity. How are we on the time?
We have still, for this presentation, about 3 minutes.
Okay, great. Right. So I'll show you 2 queries. One here, which is decrease price of all Mexican premium kits by 10% if they are on promotion for one of the retailers only. What happens actually here, this is a new experimental workbench page. This is not our product. Aaro said that I have to point out that we create infrastructure, not products like this. So, but the underneath tech here is actually one tool call, which has loads of arguments. And then it's turning a vertical trajectory to a horizontal one. So it's almost like, imagine a function of 10 arguments. And then you have a query which has, it has a channel, it has a reduction, it has premium, and it has a promotion filtering. So if your argument list has all of that, agent can fill it kind of like a type form in one go, and then it becomes instantaneous. But this is only possible if you have the KV. If you don't have it, you are bound to do inspect tables, inspect this, inspect that. But once you have it, it unlocks this kind of efficiency, which is 4.75 seconds. This was also Cerebra's GLM 4.7. Yesterday we got 5.0, but it takes time. I'll show you one more, which I think is even cooler. You can see I run a lot of these because I don't trust demos to go well, but I'll run this one more and I'll explain why this is interesting. So you can see now it's resolving groups, and it's taking actually quite some time because there are many groups. So you have the current dollar amount. So it actually needs to look at all the dollar amounts of thousands of products. And it needs to determine once that it needs to operate on. And it needs to create buckets. So it's not only that you're creating a range, but within that range you're creating sub-buckets. And within the buckets you are creating actions. And this one has 26 actions created. And this takes a lot of time to do this. This was like 2 minutes, 30 seconds at least. And now it's actually quite close to the simple query that we just had. And this is just because it uses KV. So when you have agent task that's approaching complexity, multiple tasks, you will want to use, I think, pointers, because then you find that the gradient that we saw in the beginning, you will get that kind of to come down slightly. So then you can scale your solution. Yeah, I think we can take questions now.